Langat 2 Water Supply Project is a major water supply project for the state of Selangor and the Federal Territory of Kuala Lumpur, envisaged to provide the water supply needs of the state up to year 2025. The raw water source for the Langat 2 Water Supply Project is from the Pahang-Selangor Raw Water Transfer Project, which will convey raw water from the Sungai Semantan in the state of Pahang through a transfer tunnel to the state of Selangor. This project was planned to be carried out through two phases, which is Phase 1 and Phase 2, whereby each phase is capable of treating and distributing 1,130 million litres per day of water to the needed areas. The Phase 1 is located in Hulu Langat, which is built across Sungai Langat to supply treated water to the northern and western corridor. Treated water, which is supplied from the Langat 2 water treatment plant, will be pumped to the Bukit Enggang Balancing Reservoir and the Hulu Langat Balancing Reservoir. From the balancing reservoirs, the treated water will be distributed via separate bulk distribution pipelines to the northern corridor, western corridor, and the existing Langat Balancing Reservoir. The works under this contract comprised the design, manufacture, testing at manufacturer's works, delivery, installation, pre-commissioning, testing, setting to work, performance testing, and commissioning of all plant and equipment for the water treatment process to supply 1,130 million litres per day of potable water. Water treatment process. Aerator and pre-oxidation tank. Aeration process is incorporated into the treatment process mainly to remove iron, manganese, and other dissolved gases from the raw water. The water is aerated using cascade-type aerator, whereby impurities are oxidized naturally by oxygen from the atmosphere as the water overflow from the inlet chamber staggeredly. Potassium permanganate is dosed at the inlet for the pre-oxidation tank to assist in the oxidation of iron and manganese. Chemical mixing chamber. Mixing of pre-treatment chemicals is carried out at various points upstream of flocculation tanks using hydraulic energy. The first chemical is the chlorine solution in the raw water pipeline prior to the aerator to prevent algae growth in the process structures. Lime slurry is dosed at the aerator to increase the pH of raw water if required. Liquid polyaluminium chloride (PAC) for coagulation is injected at the inlet to the channel static mixer. Dosed water from the chemical mixing chamber is then distributed into each flocculation tank. For each substream, the dosed water enters 5 flocculation tanks, each installed with 4 numbers of mechanical flocculator, driven by variable speed motors. Polymer is dosed at the inlet of each flocculation tank for floc strengthening. Clarification process involves separation of solids generated from the flocculation process from the water. The lamellar clarify system operates according to the countercurrent or upflow principle. Water enters and exits the system through channels, which are divided into 2 sections consisting of the lower section for incoming water and upper section for discharge of clarified water. Raw water from the flocculation tank is distributed evenly into each lamellar cell from the bottom of the channel. Outside, on the channel walls, lamellar plates are installed at an inclination of 55 degrees to the horizontal. The water flows upward between the lamellar plates. Clarified water is directed to the outlet channel. Solids which settle on the lamellar plate form a layer which slides down on the lamellar plate and settles into the compartment underneath the lamellar plates. The complete system is virtually maintenance-free. Any cleaning required is carried out during operation. For easy maintenance, each individual lamellar plate is retractable. Sludge that settles from the clarification process will be collected in the hoppers. The sludge will then be discharged from the hoppers under hydrostatic pressure through a discharge pipe and transferred to the sludge-holding tanks. Filtration plant. Besides the clarification plant, the filtration process is also the key treatment process in water treatment plant. Rapid gravity dual media filters are constructed for this plant. The filtration plant is the downflow open gravity, constant flow, constant head type. Filter media used in this plant are sand and granular activated carbon for the removal of minute flocks carried over from the clarifiers and removal of taste and odor. Clarified water from the clarifiers are distributed into 12 filters for each substream. Filtered water is collected in the underdrain systems, which consist of concrete false floor and subsequently piped to a collection tank to be transferred to the clear water tank. Process control building. The process control building mainly houses the filter's backwashing facilities. The filters are backwashed using air, combined air scour and water wash, followed by water wash in conjunction with surface washing. The backwash pumps and the air blowers are installed at the process control building between the filters of two substreams. The backwash pumps supply wash water during combined wash and rinsing stage. The air blowers supply air for the air scour and combined wash process. Wasted wash water is channeled to the plant for further treatment prior to final disposal. Contact tank and clear water tank. 4 numbers of adjoined reinforced concrete baffled contact tank and clear water tank are constructed. The volume of each contact tank is approximately 8,400 cubic meters, and the volume of each clear water tank is approximately 45,000 cubic meters. Fluoride and chlorine shall be dosed before the contact tank, while post-lime is dosed prior to the static channel mixer for pH adjustment. The outlet of the contact tank connects to the clear water tank for storage. Treated water pumping station. The treated water produced is being pumped to 2 new balancing reservoirs in Bukit Enggang and Hulu Langat. The Bukit Enggang pumps are designed to pump a total of 844 million liters per day of treated water through 2 lines of 2 kilometers of 1,900 mm MSCL mild steel cement lining pipe. The Hulu Langat pumps are estimated to pump a total of 290 million liters per day of treated water through 7.4 kilometers of 1,750 mm MSCL pipe. Chemical plant. The chemical plant is provided to complement the physical process of water treatment. The plant consists of potassium permanganate, polyaluminium chloride (PaC), hydrated lime, chlorine, polymer, and fluoride. Chemicals which are supplied in powdered form or concentrated liquid form will be prepared in the chemical plant and dosed to its various points throughout the plant. Storage facilities and chemical handling equipment are provided within each plant. Chlorine plant. Chlorine is often used in water treatment as disinfectant agent. Prior to the water treatment process, chlorine is dosed for algae control within the plant. Lastly, before the supply of the treated water for onward distribution and consumption, chlorine is dosed for disinfection. All chlorine solution preparation facilities and storage of chlorine drums are housed in the chlorine building. Sludge treatment plant is incorporated in the process treatment works to treat the sludge produced from treatment plant and waste wash water of filters. The sludge treatment plant comprises of wash water recovery plant, sludge thickener and sludge dewatering to recover wash water to be recycled back to the inlet before final disposal to external sites. Wash water recovery plant. Sludge and waste wash water from the clarifiers and filter backwashing is collected at the wash water recovery plant. Solids and sludge from the waste wash water is separated at the wash water recovery tanks. Supernatant is then pumped back to the aerator for recycling, while the sludge is pumped to sludge holding tanks with the sludge from the clarifier for onward thickening. Polymer will be dosed at the sludge thickener inlet pipeline to aid the thickening process. Sludge thickener. Sludge from the wash water recovery plant is further thickened at the sludge thickener with the aid of polymer dosing. Once the desired concentration is achieved, the thickened sludge is pumped to another storage tank for the dewatering process. Dewatering plant and storage yard. The dewatering process uses centrifuge decanters. The dewatering plant is constructed to cater sludge production from Phase 1 and Phase 2 of the water treatment plant. Polymer is dosed again to facilitate the dewatering process. Dewatered sludge is then discharged and collected at the storage yard via screw conveyors. Dried sludge is then ready for onward transportation to landfill. Administration building, store, and workshop are constructed to facilitate the operation and maintenance of the whole plant. The administration building houses a reception, office facility, command center, and laboratory to facilitate water analysis. Generating plant. An alternative power source is provided via backup diesel engine-driven 2 numbers of 6.6 kV generators set, rated at 5.5 MW, with synchronizing switchboard located at generator building. The generators are sized to operate the treated water pumps during power outage. For the plant operation, separate standby diesel engine-driven generators are provided. Instrumentation and SCADA system. Instrumentation is installed throughout the treatment plant for the monitoring of the operation of the plant and water quality produced. The various plant data parameters shall be transmitted to the SCADA system, where the operator can monitor them at the command center.
Firstly, site surveying works was carried out to stake out reference points and markers that will guide the safe and strategic site for the construction, and to provide the accurate information for designers in order to design a safe structure.
Site clearance operations include a set of works for land clearing, from tree and herbaceous vegetation, tussocks, stumps, moss, stones, and the removal of unsuitable materials. Later, Upon the completion of clearance works, excavation works commenced, in which the earth is excavated to the required platform level for structural works to be carried out. Suitable excavated soil is used to build up the required platform level. The filled soil is compacted using rolling method fitted with vibratory devices to achieve the maximum strength for the platforms. As for rocky areas, rock blasting and rock breakers are engaged to remove the rocks. Excavator-mounted hydraulic hammer was used during the rock breaking process in certain areas. And rocks are drilled in a series to a certain depth and filled with explosive material for rock blasting. Later, loosened rock was transferred to designated areas using excavator and dump trucks.
Slope protection works has been carried out as slopes are a major point source erosion problem that can result in serious sediment flow to lower catchment sites during heavy rain. Grass turfing and slope drainage are constructed to regulate and prevent free flow of water along slopes. Open trench pipeline method was used in this project, which involves 4 number of DN 3000 raw water pipeline from Pahang Selangor raw water outlet portal. And 2 number of DN 1900 treated water pipeline to Bukit Gang Balancing Reservoir. And 1 no. of DN 1750 mm to Hulu Langat Reservoir. This method involves the progressive excavation of an earth trench, and laying of sections of pipeline on a bed of gravel or supports. Once a section of pipeline has been completed, the trench is backfilled and the area restored.
Lean concrete works has been carried out to provide the uniform surface to the foundation concrete and to prevent the direct contact of foundation concrete from the soil. Upon completion of lean concrete works, reinforcing of rebar works was in progress to provide strength and helps to support the concrete structure by absorbing and distributing the tension when concrete expands and contracts due to climate variations. Tie wire is used on the reinforcing steels to prevent displacement during construction activities and concrete placement. Later, slab foundation works commenced, in which thick slab of concrete that is typically 4 inches to 6 inches thick in the center poured directly on the ground, which the foundation is reinforced with steel rods, rebar. Column casting works was carried out once foundation works completed. The reinforced concrete column is a pillar that stands as the carrying channel for the structure above it. A temporary formwork or mold are built at the steel columns for concreting works and will be removed once the concrete is dry. Later, concrete mixture is poured in the mold and vibrated.
Brickworks commenced upon completion of column casting works. High-grade clay bricks were used to withstand the severe weathering and to exhibit better thermal insulation. Thermal mass and moisture that the brick has absorbed can help to keep the temperature inside the building relatively constant. Later plastering works was commenced for interior and exterior of wall structure, whereby a thin layer of mortar applied over the masonry, and it acts as a damp-proof coat over the brick masonry work. Plastering work also provides a finished surface over the masonry that is firm and smooth, hence it enhances the appearance of a building. Finally, painting is done to protect the surface from the effects of weathering and to provide a decorative finish. Tiling works for floor, walls and staircase was being laid to give the aesthetic final look for the building interior and easy maintenance of the plant buildings. Epoxy floor coatings works was carried out over concrete floors in certain areas to provide a high-performance, smooth, and durable surface that can last many years and withstand heavy loads. Building services works consists of mechanical, electrical, and plumbing. MEP are the three aspects linked to every building project. That includes design, construction, and deals with the setup, functioning, and maintenance of the three major elements of a building project. MEP is an integral part of a building project. The design of the electrical services has taken into account of the building form, the characteristics of the building, the occupancy trends and orientation of spaces. The electrical services installation comprises electrical supply, electricity center and main distribution, power distribution services, lighting services and communication services. Conduits and cable tray systems are laid according to the drawing and design intent for each and every structures at treatment plant facility, to support wires and insulated cables, for the necessary power distribution without any disruption. Fire protection system is an important component of a building's safety plan. All plant structures are equipped with fire protection system, which consists of CO2 high-pressure cylinder, fire alarm and suppression system. Fire suppression systems are used to extinguish or prevent the spread of fire in a building, which uses of dry chemicals and/or wet agents to suppress equipment fires. The plant buildings is equipped with turbine and direct drive fan ventilation system, to provide a continuous supply of fresh outside air, which maintains temperature and humidity at comfortable levels and to reduce potential fire or explosion hazards. The warm air that's drawn out using an exhaust fan is then pulled through a ducting system and expelled outside. Centralized air conditioning system was installed, to remove heat and moisture from the interior of an occupied space, to improve the comfort of occupants to achieve a more comfortable interior environment. The units also provide filtered cooled air as required to maintain the service conditions necessary for the efficient operation of electronic equipment in the vans. Overhead cranes installation has been carried out at each plant buildings, to move loads and other material handling processes. The sizes of the overhead cranes varies for each plant, depending on the load weight to be handled. Each plant is equipped with electrical control panels, which are designed and used to control mechanical equipment in the particular plant. The integrated control panel system is designed in complete compliance with Programmable Logic Controller (PLC) and SCADA systems. Motor Control Center, MCC, is an assembly to control all electric motors in a central location. It consists of multiple enclosed sections, having a common power bus and with each section containing a combination starter, which in turn consists of motor starter, fuses or circuit breaker, and power disconnector. Switchboard panels directs electricity from one or more sources of supply to several smaller regions of usage. It is an assembly of one or more panels, each of which contains switches that allow electricity to be redirected. Automatic mains failure, AMF. Panels make the power switch to emergency standby generators, in the event of a significant loss of mains power or total blackout. Local plant control panels is used mainly as a local point to control motors and pumps in the plant. UPS system panel provides battery backup for the electrical control panels, when the electrical power fails or drops to an unacceptable voltage level. Supervisory panel is an overall monitoring of individual process controllers, which gives the operator an overall plant process view, and allows integration of operation between controllers. Smart water monitoring system checks the purity of portable water that the consumer receives, by measuring 5 qualitative parameters of water viz. pH, temperature, turbidity, dissolved oxygen and conductivity. Valve is a mechanical device that regulates, controls or directs the flow of a fluid by opening, closing, or partially obstructing fluid flow. Chambers which act as a room for the valves are constructed at each valve units, to ease the operation and maintenance works of the valves. Gate valves or scour valves and other pipe fitting valves are installed at each of these pipe joinings to control and regulate the flow of water. Air valves are positioned at the highest point and the function of these valves are to release air trapped in the pipes. Flow meter was installed to measure the flow rate or quantity of liquid moving through a pipe and accurate monitoring flow control. Slide penstocks installation was carried out for flow control, regulating the water level, and distribution of channel flow, in open channels, pits, tanks, compartments and pipelines. Electric actuator installation was carried out at valve chambers to control or moves the mechanism to regulate the water flow. In any water treatment plant, pumps play a vital role. They help in collecting the raw water from different parts of the plant, and transfers to the treatment plant. Once the water is purified, pumps then assist in moving the treated water to places where it is required, or to a storage tank. Centrifugal pumps was used in pumping station to pump the treated water to balancing reservoirs. Whilst in process control building, the pumps was used for filter backwash. Screw pumps was used in sludge treatment plants, to transport of viscous fluids with lubricating properties, to treat the sludge produced from treatment plant, and waste wash water of filters. Air blower is used at process control building to supply air for the air scour and combined washing process of the filter. Surge tanks are installed to relieve excess pressure caused by water hammer, and to provide a supply of water and which reduces negative pressure if a valve is suddenly opened. The large increase in pressure can cause pipes to crack and in some cases burst. Landscaping works commenced to create a joyful environment, good appearance and natural beauty. The landscaping was designed with drives, walks, lawns, shrubs, stone benches, flower beds and trees to create a warm and inviting environment.
Anti-climb fencing with Fence Intruder Detection System (FIDS) was installed to provide the highest degree of security with excellent see-through.
Surveillance systems has been installed at strategic locations at the water treatment plant area, for observation and security purpose. The visuals from the surveillance camera are transmitted to guardhouse and control room for monitoring purpose. Access roads are constructed to provide access onto the site, into specific work locations, for the construction of the water treatment plant, which is designed with dual carriageway to provide access from main entrance.
Laying of aggregate base course, which consists of crushed stone, was carried out to create stronger base support, and it is placed evenly on the road surface. Later, road pavement works laying of asphaltic concrete binder course ACBC commenced. Upon completion of ACBC works, laying of asphaltic concrete wearing course ACWC was carried out as the final layer.
Furniture, fixtures and equipment, FFE, works commenced to create a comfortable and accessible for the employees and customers, which includes shelving, modular partitions, including internal wiring and devices, appliances, movable furniture, desks, chairs, computers, servers, electronic equipment, data and phone equipment, tables and racks. As qualitative and quantitative measurements are needed from time to constantly monitor the quality of water at the treatment plant, Water Analysis Laboratory is designed and equipped with all necessary facilities for the analysis of drinking water. The facilities include all physical, chemical, and microbiological testing procedures to fulfill regulatory requirements and to maintain the water quality and safety. A modern, functional and technologically equipped auditorium is constructed at Administration Building. The auditorium is designed for training, presentations, performances, meetings, interactive learning and discussions. The auditorium were installed with tiered seating, enabling those sitting right at the back to be able to see what is happening at the front and equipped with high-quality audio-visual equipments. Supervisor control room located at Administration Building is vital for the water treatment plant, to effectively monitor SCADA information streams received from the plant buildings. The supervisory control and data acquisition, SCADA, is a control system architecture which uses computers, servers, networked data communications, and graphical user interfaces, for gathering and analyzing real-time data.
Commissioning works has been carried out upon completion of the project to assure all systems and components maintained according to the operational requirements of the owner. Finally, performance testing was done to check if the plant meets the specifications under normal operating conditions before handing over to the client. The Langat 2 water treatment plant was successfully completed within its stipulated timeframe due high commitment level of the manpower resources working tirelessly until the completion of this project despite the problems and challenges faced during the construction period.